So today we will learn SLR parsing. What is SLR parsing? Now we previously learned LL parsing, and for that we used to create some LL parsing table and we used to check if the given grammar is LL1 or not. So in this case we have to answer questions like check whether the given grammar is SLR1 or not. Check whether the given grammar is SLR1 or not. Again, same kind of questions are asked for SLR1. Now, what is SLR1 parsing? So we have top-down parsing and we have bottom-up parsing. Now, a top-down parser is one which starts from the top, goes down to the bottom. Bottom-up parser goes from bottom to up. Now, top-down parsing has examples like RDP and LL1 and LL parser. Bottom-up parser has examples like LR parser, which consists of SLR and CLR. So this is what we are going to learn today. SLR parsing, which is a type of bottom-up parser. Now let us consider an example where we have a given grammar E tends to T plus E slash T, or no, it's going to be or T, and then we have T tends to ID. Now suppose we want to parse ID plus ID. This is a bottom-up parser. So we will not start from the grammar. We will start from the bottom and then we will go to the top. So this is the bottom. We will start from the right hand side, which is the bottom, and from here we will go to the top. So in this case, we can reduce this ID back to T. So we will reduce ID back to T. We can also reduce this ID back to T. So we will reduce this ID back to T. Now if we break down this grammar, this one which is E tends to T plus E, and then there is an OR symbol, so we can break it at the OR symbol and we can rewrite E tends to T. E tends to T plus E, E tends to T. So we just broke it down into two different grammars, okay, two different productions. Now let us say that this is a T, okay, so we went from ID to T, so we went from ID to T. This is just an example, this is not how to solve the question, this is just for understanding purpose. So ID is converted into T, so ID is converted into T. Now we can convert T into E, so we can convert T and reduce it into E, because E tends to T, so we can go back in the reverse and we are going from bottom to up. This is a bottom-up parser, so we will go from T to E. Now look at this, T plus E, T plus E. This is T, this one, and this is E, this one. So E plus T, this one. So what is this E plus T? This can be reduced as E, because we know that E plus T is E, so it went back. So E plus T is E, so it just went back. So we went from bottom to up. This is how bottom-up parsing works. This is just for understanding purpose. What do we mean by bottom-up parsing? But this is not how you solve the question. So let's start solving the question in the right way. So this is an example that we have. E tends to T plus E or T, and we have T tends to ID. This is a simple example. If you understand this one, you can solve any example. Now, what are the steps? So let us first start with the steps and then we'll come back to this. So steps. First step is to create augmented grammar. The second step is to construct the graph. Third step is to create parsing table. Fourth step is to look for overlap or conflicts. Overlap is as same as conflict. Overlap and conflict is the same thing. Now let us start with the example. The first step was to create an augmented grammar. So let us create an augmented grammar. This is a normal grammar, and from this we will create an augmented grammar. You can see that E goes to T and T goes to ID. So we are starting with E, then we are going to T, and then T is going to ID. So it means that the beginning, we can write E as the beginning of all this grammar. So we can write this, we can rewrite this as E dash tends to E, right? We can write E dash tends to E. And so what is happening? We are starting with E dash, which is going to E, and this E is going to this E, and this E is going to this T, and this is also going to this T is going to this T, and this T is going to ID. So we just change the path and we are starting from E dash. And when we start from E dash, then we can write the remaining grammar, which is E tends to T plus E or T, and T tends to ID. So this grammar, we just changed this grammar to this grammar, and this is called as augmented grammar. So did we write an augmented grammar? Yes. So step 1 is completed. Step 1 is done to create an augmented grammar. Now let us copy this augmented grammar and go to the next page. So we'll take this augmented grammar and we'll go to the next page. Now in this next page, we have to start to construct the graph. How do we construct the graph? So to construct the graph, you need to understand how does this parsing really work. So for the parsing to occur, you have to understand that this is a look ahead parser. So we are not doing SLR parsing, we are doing SLR 1 parsing. And 1 means we are looking ahead at one symbol. Look ahead symbol. How many look ahead symbols are there? Only one. So there is one look ahead symbol. So in this case, we will use dot to understand our state or position. To understand our state or position, we are using dot. Now how do we use the dot? So let us start. Now we will use E dash tends to dot E. E dash tends to dot E. So what we did, we gave a dot here. Now how does the dot work? How does the dot work? So if, okay, let's write it in text. If variable, then derive. If terminal, then move, then nothing. Okay, just remember these two simple rules. If there is a variable, then you have to derive. If there is a terminal, then you have to do nothing. What is a variable? What is a terminal? Okay, instead of writing variable, we will write non-terminal. Non-terminal is known as variable. So we will write non-terminal. Now there is this non-terminal E, there is this non-terminal T, there is this terminal plus, and there is this terminal ID. Now is E, this is for dot, is E a non-terminal or a terminal? E is a non-terminal. So if dot is with the non-terminal, then you have to derive E. How do you derive E? You have to use this E and you have to derive like this. So you take this E, which is this one, and you are deriving this E now. How do you derive this E? By looking at this E, which says E tends to T plus E, and don't write or, instead you have to write E tends to T. So you just separate this or symbol into two different productions. So now we derived this E into these two productions. And then we have to add a dot here and add a dot here, because whenever we are starting from the leftmost derivation. Now, This dot is with this t and this dot is with this t. Is this a non-terminal? Yes, it's a non-terminal. Is this a non-terminal? Yes, it's a non-terminal. If there is a non-terminal, then derive it. So if there is a non-terminal, then derive it. How do you derive t? Just look at this t. This t says that t tends to id. So t tends to id. So you successfully derive t as t tends to id. And then you have to give a dot here. So this is how you create your first step. And this is also known as the first state. This thing is your state number 1 or item number 1. This is the first state, okay? So we will call it 0, state 0 or item 0. So let's call it item 0, I0. Okay, now this dot will go here. So this dot is showing us the state or the position of the parser. So this dot has a position before E, and when this dot has a position before E, in the next state it will read E. So this dot will now read E. So you will write E above the arrow, and then you will write E dash tends to E, and dot will now go in front of E. So this dot have read E, so we write E right here above the arrow, and after reading E, the dot goes in front of the E, and this is a item number 2, I2. Now look at this. This dot will read T and this dot will also read T. So let us create another item that reads T. Now this dot is reading T and this dot is also reading T. So what will happen? So E tends to T. This dot will read T and it will move here. So T dot plus E. And this dot will move here. So E tends to T dot. You can understand this, that this dot went here and this dot went here after reading T. And this thing is now item number 2 or item number, okay, the first item was item number 0. So this is item number 1 and this is item number 2. This is I2. Now this thing, which is item number 1, is the augmented grammar, and augmented grammar, when it reaches at the end, it is also called as acceptance state. Acceptance. This is acceptance state. So this has achieved the acceptance state. Now this one needs to be derived further. So this dot has to read ID. So when this dot reads ID, we will write ID above it because this dot is reading ID, and we will write T tends to ID dot. Why? Because this will read ID and this will go here, and this creates item number 3. I3. Okay. So now we have 4 items. Now you can see that after this dot, after this dot, there is nothing to do. So we can call it a reduced state, R state, a reduced state. So we can write here reduced state. It is a reduced state. Now in this one, after T, this dot cannot go anywhere else. So this T is also reduced state. Only this T is reduced state. So we can just write R in bracket just to remember that this is a reduced state. Now look at this one. Is this a reduced state? No. There is a dot. And you can see that when dot is in front of a terminal, so when dot is in front of a terminal, then do nothing. So when dot was in front of terminal, it did nothing, it just went to the next step. When dot was in front of a non-terminal like this, it has to derive a terminal like this. Now, we have to go to the next step. You can see that this I3 is reduced, so we will not do anything with this. You can see that this I1 is acceptance, so it is accepted, so it is also finished, so we will not do anything with this. Only this thing is now remaining. Even in this thing, this part is finished, this is reduced. We have R written in bracket, so it is reduced. So only this equation is remaining now. So how do we solve this equation? So what we will do is, we will create an arrow, and this dot is before plus, and plus is a terminal, and if there is a terminal then do nothing. So we will write plus above the arrow, and then we will write E tends to T plus, and where is the dot now? Dot will go in front of the plus. So dot will go in front of the plus and E as it is. Now do we need to write this? No, because this equation is finished. Now we cannot go further. Dot is in front of T, it is reduced, it is finished. So we cannot go further. So it's okay. Now look at this equation. We know that if dot is in front of a non-terminal, then we have to derive it. So dot is in front of a non-terminal. This is a non-terminal, so we have to derive it. How do you derive it? To derive it, you have to look at the first graph. We have to derive E. So E tends to T plus E, or you can just look at this question. E tends to T plus E or T. So you just have to write it as it is. E tends to T plus E, and you don't have to write or, you don't have to write E tends to T plus E or T. You have to write it separately. So you write T plus E separately and T separately. You write it like this, and when you create a new derivation, you have to keep the dot in front, just as you did in the first step. There was dot in front of E, so you created E tends to T plus E, this one, and E tends to T, this one, and then you added dot in front of it. So similarly, you have to add a dot in front of it. And now there is a dot in front of T, and when there is a dot in front of a non-terminal, then we have to derive it. So let's derive T. T tends to ID is the derivation. So let us write it down. T tends to ID, which is the derivation, and then you have to write dot in front of it. Now this equation looks very similar to the first equation, which is correct. So we are almost near the end of the equation. Now this is a different item. We have finished third item last time, so this is item number 4. So let us write I4. Now let's go to the next one. Now if now dot was in front of E, so dot has observed E, and after that what happens? After that we get E tends to T plus E dot. So this dot just went in front of E, and since it has observed E, we will write E in front of the arrow. Now there is just dot in front of one E. So this item is completed. This item is completed. We will call it item number 5. Item 5. What about the other ones? So look at this. If dot is in front of T, then we will have to create an arrow with T. But we already did it. Dot was in front of T, dot was in front of T, we created an arrow, and then this equation comes in. So if we create an arrow with t, same equation will come exactly like this. Exactly like this, another equation will come into place. So we will see exactly this equation when we derive an arrow with t. So instead of deriving an arrow with t, what we will do is we will just go back and then we will just connect this item to this item back, and we will write t above it, because when dot reads t, this dot goes in front of t, and this dot has already went in front of t, so this is correct. This dot will go in front of t after reading t, so this dot is already in front of t, so it is also correct. Now look at the last one. T tends to dot id. Now when there is a dot in front of terminal, you have to do nothing. So you will just go to the next step. So when you go to the next step and dot has read id, you will create t tends to id dot. But there is already a t tends to id dot, because in last equation also the dot has read id. So instead of creating this again second time, we will just erase this, and then we will take this arrow back to the first equation, because this dot just needs to go in front of id and this dot is already in front of id. So we will write id above the arrow. So this is how you complete the graph. This is the complete graph. So this is how the graph completely looks like. This is how the graph looks like. Now we have to create a table. So let us just keep the graph and remove everything else. So this is the graph. So first we have to now create a table. Now in this table we have to create the following columns. The first column is the column of state. This is called as state column. So let us write state. So this is called as state column. What is a state? State 1, state 2, state 3. Each item is a different state. Now the second column is this part. We can divide into two different parts. The first part consists of terminal symbols and the second part consists of non-terminal symbols. How many non-terminal symbols do we have? We have E and we have T. So we will write E and we have T. So these two are non-terminal symbols. How many terminal symbols do we have? We have ID, we have plus, and the final non-terminal symbol that we have to write in a table is dollar. Dollar is the final non-terminal symbol that we have to write. So ID plus and dollar, which basically means this basically means that the table is complete. Now we just have to fill in the values. How many states do we have? We have 0 to 5, so we need 6 rows. So we have 1, 2, 3, 4, 5 and 6. So we have 6 states now. Now how do we fill the column? First state is state 0, item number 0, then 1, then 2, then 3, then 4, then 5. So these are all the states. Now let us start with ID. When state 0, this is the state 0, it goes to ID, it reads ID, then what happens? When state 0 reads ID, what happens? Just look at this. This is state 0 and state 0 reads ID, then what happens here? This is item number 3, and if there is item number 3 and this is a terminal symbol, you have to write S3. S3, which basically means that state 0 went to state 3. Now look at plus. Is there plus above any arrow? No, so we don't have to write anything here. Now look at dollar. Now dollar is not required to be written here. What do you mean by dollar? Dollar is to be written when there is an acceptance state. So is there an acceptance state in state 0? No. There is an acceptance state in item 1, which is state 1. Item 1 is state 1. So there is acceptance state, this one. Then you have to write it there. So let us look at E. At state 0, when you go to E, when you read E, what happens? When you read E, you go to item number 1, which is item 1 is state 1. So you have to write 1, only 1. If there is a terminal symbol, then you have to write S1, S2, S3. If there is a non-terminal symbol, then you only have to write 1, 2, 3, not S1, S2, and S3. Okay. Now look at T. When state 0, this is state 0, reads T, so it reads T, then what happens? It goes to this item, which is item number 2. So you have to write 2. That is how easy it is. Now look at state 1. Which is state 1? This is state 1. State 1 is acceptance state. So you just have to write at the dollar, you have to write acceptance. So you have to write acceptance there. Acceptance. That's it. You have to write acceptance in that small cell. Now, you don't have to fill anything else because there is nothing else in item 1. Go to item number, state number 2, which is item number 2, this one. Now in this state, you can see that this is the state number 2. Now in the state number 2, what happens? In state number 2, if you look at this, which is T dot, there is a small r, which means it is reduced, because after T dot, we cannot shift the dot further ahead. It means it is a reduced term. And since it is a reduced term, what we have to do is we have to consider it as reduced. So I'll just write it here. This is item number 2, this one. And in this, there is E tends to T dot plus E, right? I'm just copying this. And E tends to T dot. And this is a reduced term. Because after dot, you cannot go anywhere else. So this is final reduced term. So if there is a reduced term like this, then you just have to write R. But where will you write R? Will you write it here? Will you write it here? Will you write it here? So if you are solving for LR0, if the question is about LR0, then you will write R in each of these boxes, in 3 boxes. But we are not solving LR0. LR0 is exactly like SLR1, but you have to write R in all 3 boxes in LR0. But now we are solving SLR1. And in case of SLR1, what you have to do is, you have to go back to E and you have to find follow of E. What is follow of E? If you find the follow of E, from this, you will find that, let us go back to our first question. So this is the first question. So what is follow of E? This is E, and since after E there is no other symbol, you will go back here and you have to find follow of start symbol. What is follow of start symbol? Follow of start symbol is always a dollar. So you have to find follow of E. Because dot is after T, it will go back to the first one, and you have to find follow of E. Follow of E is dollar. So you'll find the follow of E is dollar. So in dollar, you have to write R because it is a reduced term. So in dollar, you have to write R because it is a reduced term. But which number is it? It is item number 2. So you will write R2. This is how you do it. Now, let us go to the next one. Okay, there is one more thing. If you look at state 2, which is item number 2, just look at this item number 2, state number 2. This is state number 2. In this, there is one reduced term, but there is also this term. Where does this go? That is what you have to see. So, in this term, you can see this term goes to the next term with plus symbol. So, there is this plus symbol. So, in plus symbol goes to I4. This state, this item from state 2 goes to item number 4 with plus symbol. So below the plus symbol, you have to write 4 because it goes to fourth number. But since it is a non-terminal, you don't write only 4, you have to write S4. So it is S4 like this below the plus symbol. Now item number 2 is done. So item number 2 is finished. Now we will go to the next one, which is item number 3. So I'll just write this item number 3 again so you can see it clearly. This is how the item number 3 looks like, I3, and we know that it's reduced. So it's a reduced item. So when it's reduced, because dot cannot go further anywhere, so it's reduced. So we know we have to write R. And this is state number 3, so we are talking about state number 3. In state number 3, we can see that we have to find the follow of the first term. So we have to find the follow of T. What is follow of T? Let us look at the question. So let us look at the question. This is T. So we have E tends to T plus E, and we have E tends to T. What is follow of T in this case? So follow of T is follow of E. Follow of E is dollar. And in this case, there is one more T. So follow of T is plus. So what is the follow of T? Finally, the follow of T is plus and dollar. So now, follow of T is plus and dollar, which means you have to write R in plus and dollar. So this is state number 3. So in state number 3, you will write R in plus and dollar. But this is third number. So you have to write R3 here and you have to write R3 here. Now, the item number 3 or state number 3 is finished. Okay, now fourth state. Fourth state is, this is the fourth item. In this item, you can see that we have these items where I4 goes to I5. So I4 goes to I5 at E. So this is the fourth state that goes to I5 at E. It reads E, then it goes to the fifth state. So it reads E and it goes to the fifth state. And since E is a non-terminal symbol, so we don't need to write S5, we just need to write 5. Now, we don't have to write anything under T. Okay, we can see that the state 4 is going back to state 2 with T, because when this dot reads this T, it goes back to the state number 2 after reading T. So it goes back to state number 2 after reading T. So this is also finished. Now, state number 4 goes back to the state number 3 after reading ID. So it goes back to the state number 3 after reading ID. So we will write S3. We don't write only 3, we write S3 because this is a terminal symbol, and if it is terminal symbol, we write it with S. Now, it went back with T, it went back with ID, and it went to the next state with E. So ID, E and T. This one is finished. Now, let us look at the fifth number state. If you look at the fifth state, this is the fifth state. This is a reduced state. Fifth state is a reduced state. And where do you have to write the R? You have to go to the E and you have to find follow of E. And what was the follow of E? It was dollar. So in dollar you will write R5. R5. You will write R5 in the dollar. Now you can see that there is no conflict in this. Sometimes there is a conflict in that, where if you look at this box, there is S4 and sometimes R will also appear in this S. So you have to write it like S4 upon R. So in this case, it is called as shift reduce conflict. If sometimes there are two different R, there is R2 and R2 and R3 in same box, it is called as reduce conflict. Sometimes there is two different S in the same cell, and it is called as shift conflict. So shift conflict, reduce conflict, and shift reduce conflict. If there is any of this conflict, then we can say that it is not SLR. The given grammar is not SLR. But do we see any conflict in this table? There is no conflict in this table. So therefore, it is an SLR. So what we did, we created an augmented grammar, then we constructed this graph, and then we created a parsing table. We created this parsing table, and after creating parsing table, we look for overlap or conflict. Is there any overlap or conflict? No, there is no overlap, no conflict. It basically means that given grammar is SLR. So we just have to check if given grammar is SLR or not, and we finally successfully checked it.